I welcome you to my YouTube channel SVK Coaching Classes. Myself Vasan Kumar S, working as an assistant professor at Mysuru Royal Institute of Technology. In this session, we are going to discuss on the topic called off-range Fourier series. So, as in the topic itself, we have the name called off-range Fourier series. As we discussed in the earlier classes, called Fourier series of period 2 pi. The interval was 0 to 2 pi, and for arbitrary constant it was 0 to 2l. But in this topic, we are going to discuss called off-range. The interval will be of the form, in the off-range, the interval will be of the form 0 to pi and 0 to l. The interval will be of the form 0 to pi and 0 to l. So, in this interval, we are going to solve all the problems of off-range Fourier series. In off-range Fourier series, we have cosine off-range series, cosine off-range Fourier series, and one more we have sine off-range series, sine off-range Fourier series. So, in this session, we are going to discuss the problems on cosine off-range series. Cosine off-range series. Now, we shall see the problems on cosine off-range series, and we shall see the formula for cosine off-range series. So, now we shall see cosine off-range series formula. Cosine off-range series formula of the interval 0 to pi. Of the interval 0 to pi, and another interval called 0 to l. So let us see the formula for this. The f of x, the Fourier series is defined for cosine off-range series is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n x, where a naught is defined as, where a naught is equal to 2 by pi integral 0 to pi f of x dx, and similarly an is nothing but 2 by pi integral 0 to pi f of x cos n x dx. So this is the formula for Fourier's cosine off-range series of the interval 0 to pi. F of x is defined as, the Fourier series is defined as a naught by 2 plus summation n equal to 1 to infinity a n cos n x, where a naught is what? 2 by pi integral 0 to pi f of x dx. What is a n? A n is 2 by pi integral 0 to pi f of x cos n x dx. You can remember, which is nothing but this is nothing but an even function. It is like the formula is as similar as even function problems. Similarly, for the interval 0 to L, the formula is given as follows. The Fourier series is given as f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by L. So where a naught is defined as, where a naught equal to 2 by L integral 0 to L f of x dx, and similarly a n equal to 2 by L integral 0 to L f of x cos n pi x by L dx. So, as we are studying two intervals here, how to remember the formula? You may feel such doubts here. See here, how to remember? Just you remember the interval of the formula 0 to L. That is enough. F of x, for the interval 0 to L, f of x is defined as what? A naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by L, right? Similarly, where the a naught and a n is defined as A naught is nothing but what? 2 by L, 0 to L f of x dx. And an is defined as 2 by L, 0 to integral 0 to L f of x cos n pi x by L dx. Right? In place of just L, replace L by pi. You are going to get the formula for the interval 0 to pi. In this whole thing, just replace L by pi. You are going to get the formula for 0 to pi. This is the way to remember the formula for half range cosine series. Half range cosine series. Here, when you expand this series, you are going to get only cosine terms. Such functions are called as cosine half range series. Next, we will see the problems on cosine half range series. Now, consider the problem. Obtain the half range cosine series. Half range cosine series for the function f of x equal to x minus 1 whole square in the interval 0 to 1. In the interval 0 to 1. So, 0 less than or equal to x less than or equal to 1. So, write down the given function. Go with the solution. Write down given f of x is x minus 1 the whole square in the interval 0 comma 1. So, which is equivalent to this interval is nothing but 0 comma L. So, therefore, I can say that where L, the value of L is 1. The value of L is 1. I want to find out the value of L when the given interval is constant, arbitrary constant. So, you are required to find the value of L. So, whatever the value ends here, that will be the value of L. So, don't forget here. It may be 0 to 2, it may be 0 to 3. Directly you can write down the value of L as what? 2, 3, 4 like that. So, now the Fourier series, the cosine half range series, the cosine half range Fourier series is given by the formula is f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos n pi x by L. But what is the value of L here? What is the value of L? L is what? 1. Substitute that value and name that as equation star. F of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos n pi x by 1. A by 1 is nothing but A by 1 equal to what? A. So similarly n pi x by 1 is nothing but what? N pi x. So name this as equation star. Now I want to find out the values called coefficient called a naught and an. What is a naught? Where a naught equal to 2 by L integral 0 to L f of x dx. So what is the value of L? Substitute that value of L. 2 by 1 integral 0 to 1 f of x is what? In the interval, you should observe that exactly that interval f of x lies in that interval itself. Therefore 0 to 1 in that interval the f of x is defined as x minus 1 the whole square dx. Now find out the different integral of this. It is nothing but it is of the form x power n. What is integral of x power n? 2 by 1 is 2 here. Integral of x power n is what? X power n plus 1 divided by n plus 1. Similarly here we have x minus 1 the whole square. So which is nothing but x minus 1 the whole cube divided by 3. The interval x equal to 0 to 1. So simplifying this, which is nothing but you are going to get 2 by 3 is constant. Substituting upper limit minus lower limit. 1 minus 1 upper limit. 1 minus 1 0. 1 minus 1 is what? 0. 0 cube is also 0. 0 minus 1 cube. 0 minus 1 cube. 0 minus 1 is minus 1 to the power 3 we have. Minus 1 whole cube is what? Minus 1. So 0 minus of minus 1 is plus 1. So finally A naught value is what? 2 by 3. A naught value is what? 2 by 3. I require to find A naught by 2 in equation star. So A naught is what? 2 by 3. But I require to find out A naught by 2. Therefore, dividing both the side by 2. Dividing both the side by 2. A naught by 2 is what? 1 by 3. A naught by 2 value is 1 by 3. Now, let us find out the value of An. An is what? An is nothing but 2 by L integral 0 to L f of x cos n pi x by L dx. Cos n pi x by L dx. Now, as we know that the value of L is given by 1, substitute the value of L as 1. So 2 by 1 is what? 2. 2 by 1 is 2. Integral 0 to 1. In the interval 0 to 1, f of x is defined as what? X minus 1 the whole square. X minus 1 whole square into cos n pi x by 1. Cos of n pi x by 1 is cos n pi x dx. So now we should apply Bernoulli's rule here. So go with UA rule. So U is what? X minus 1 the whole square. V is what? Cos n pi x. So now applying Bernoulli's rule here, An is defined as 2 into U, that is x minus 1 the whole square, into integral of V, that is cos n pi x, is what? Sin n pi x divided by n pi minus derivative of x minus 1 the whole square. Differentiation of x minus 1 the whole square is 2 times of x minus 1. 2 times of x minus 1 into integral of sine. Integral of sine is minus cos of n pi x divided by n pi into n pi. It becomes n pi the whole square. It becomes n pi the whole square. Plus differentiation of 2 times of x minus 1. Derivative of 2 times of x minus 1. Derivative of 2 times of x minus 1 is 2 into derivative of x is 1. Derivative of 1 is 0. 2 into 1 is 2. Minus integral of cos is sin n pi x divided by n pi whole cube. N pi whole cube. N pi whole square into n pi becomes n pi whole cube. Limit x ranges from 0 to 1. X ranges from 0 to 1. Now substituting the limits here. Now let us substitute the limits. Upper limit. Let us go for upper limit. Sin n pi 1. Sin n pi 1 is sin n pi. What is the value of sin n pi? What is the value of sin n pi? Sin n pi is 0. Sin n pi is what? 0. So therefore this term vanishes when you substitute upper limit. Let us see lower limit. When x equal to 0, sin 0 is what? 0. Sin 0 is what? 0. Therefore sin n pi and sin 0 is 0. So therefore when you apply upper limit minus lower limit, the first term vanishes. So similarly the last term also carries the same thing. So therefore sin n pi is 0 and sin 0 is 0. Therefore it is 0. You are left out with minus into minus plus take out all the constant term. 2 into 2, 4 by n square pi square into x minus 1 into cos n pi x limit x. So substituting the limit called x equal to 0 to 1. Let us see what you are going to get. So 4 by n square pi square into 1 minus 1. 1 minus 1 upper limit. 1 minus 1 is what? 0. 0 into real value is 0 minus 0 minus 1 is minus 1 into cos 0 value is 1. Cos 0 value is 1. So minus into minus plus 1. So therefore 1 into 4 by n square pi square is nothing but what? An equal to 4 by n square pi square. So now substituting a naught value and an value in equation star becomes what? Equation star f of x equal to a naught by 2 is 1 by 3 plus summation n equal to 1 to infinity. An value is 4 by n square pi square cos of n pi x. So this is the required Fourier series called cosine of range Fourier series. Now we shall see one more problem on cosine of range series. Obtain the off range cosine series for the function f of x equal to x sin x in the interval 0 to pi. So write down the given solution. Given f of x is x sin x in the interval 0 to pi. So I have explained you the formula for 0 to pi of cosine of range series. So therefore the off range cosine series is given by f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos n x. Name this as equation star. Now let us find out the values of a naught and an, where a naught is defined for the interval 0 to pi as what? 2 by pi integral 0 to pi f of x dx. The given interval is 0 to pi, and in that interval the function is defined as f of x. Therefore, what is that function? The function f of x is defined as 0 to pi x sin x. Now we have algebraic function into trigonometric function. We should apply again UA rule to find the integral of this. So which is nothing but applying Bernoulli's rule here. 2 by pi into x into integral of sine is minus cos x minus derivative of x is 1 into integral of minus cos is what? Minus sin x. In derivative of 1 is 0. So we can stop at this stage. So the limit is x equal to 0 to pi. When I substitute the limit sin pi is what? Sin n pi itself 0. Therefore sin pi is also 0. Sin 0 is also 0. So therefore this term vanishes. You are left out with minus can be taken outside. Minus 2 by pi x cos x. Substitute the limit for x cos x from x ranges from 0 to pi. So which is nothing but minus 2 by pi upper limit pi into cos pi minus 0 into a real value is 0. 0 into a real value is 0. So minus 2 by pi into pi minus pi into cos pi value. Cos pi value is what? Minus 1. Cos pi value is minus 1. Therefore minus into minus plus pi by pi get cancelled. We require the value of a naught is what? Minus into minus plus 2. This is the value of a naught. So but we require the value of a naught by 2. Therefore dividing both the side by 2, we are going to get a naught by 2 as what? 1. A naught by 2 value is what? 1. Now let us find the value called an. So what is an? An is given by 2 by pi integral 0 to pi f of x cos nx dx. In the interval 0 to pi, f of x is defined as what? X sin x. Therefore 2 by pi integral 0 to pi x sin x into cos nx dx. So it is of the form UVW. So do you know what is the integral of UVW? You don't go for such attempt. So we have a formula, a standard identity, trigonometric identity, which can be converted a product to sum. So we can use that formula. We know that sin A into cos B is given by 1 by 2 times of sin of A plus B plus sin of A minus B. Using this formula, we are going to get 2 by pi integral 0 to pi x into sin A. What is A here? A value is x, A equal to x and B equal to nx, B equal to nx. Just substitute that value, x into 1 by 2 times of sine of x plus nx, x plus nx. I will take out x as common. You are left out with what? 1 plus nx. What I am doing here, just adding a plus b, we get x plus nx. So taking common as x, you are left out with 1 plus nx. That is what? X plus nx itself. Similarly, sine of a minus b, x minus nx, x minus nx. In the same way, I am taking out x as common. You are left out with sine of 1 minus nx. The limit with respect to x. Here 2 to get cancelled. Here 2 to get cancelled. You are left out with 1 by pi. I am going to split this integral. The integral 0 to pi. X is multiplied with sine. X is multiplied for both the function. X into sine of 1 plus nx dx plus integral 0 to pi. X into sine of 1 minus nx dx. Now we shall integrate these two terms. Separately. So 1 by pi, applying Bernoulli's rule here, x u into, that is x into integral of sine is what? Minus cos of 1 plus n x whole divided by the derivative of 1 plus n x is what? 1 plus n minus derivative of x is 1. Integral of minus cos is minus sine of 1 plus n x divided by 1 plus n the whole square. So substituting the limit x ranges from 0 to 5. Integrating the second term, plus x into integral of sine is minus cos of 1 minus n x whole divided by 1 minus n minus derivative of x is 1 into integral of minus cos is minus sine of 1 minus n x whole divided by 1 minus n the whole square. So substituting the limit x equal to 0 to pi in both the terms, sine of 1 plus n pi and sine of 1 minus n pi will be 0. Similarly, sine 0 is also 0. We can strike it off the term called sine of 1 plus n pi or n plus 1. Here also it is sine of 1 minus n pi is 0. Sine 0 is also 0. So we are left out with these two terms. So now taking the remaining terms here. So we are left out with 1 by pi into minus x into minus is minus x cos of n plus 1 is nothing but 1 plus n. 1 plus n is nothing but what? N plus 1. X whole divided by n plus 1. And you are left out with here plus into minus. Minus x of cos of minus theta. Cos of minus theta is always cos theta. So I am taking out minus common here. So we are left out with cos of n minus 1 x whole divided by, similarly I will take out minus sign here. So you are left out with minus of n minus 1. Limit x ranges from 0 to 5. So simplifying this again, so you are left out with 1 by pi minus by minus is what? Plus. Minus by minus is what? Plus x. I am writing positive term first. X into cos of n minus 1 x whole divided by n minus 1 minus x cos of n plus 1 x whole divided by n plus 1. Limit x ranges from 0 to pi. Now substitute the limits. 1 by pi upper limit. I will substitute for both upper limit pi into cos of n minus 1 pi divided by n minus 1 minus pi into cos of n plus 1 pi divided by n plus 1 minus lower limit. This is upper limit minus lower limit. Both the term containing x here. When I substitute x equal to 0, therefore 0 into real value is 0. So 0 into real value is 0. 0 minus 0 is 0. So lower limit is what? 0. So therefore you are left out with, you can take out pi common here. Pi by pi cos of, and also apply the definition of cos of n pi. Cos of n pi is what? Minus 1 power n. Cos of n pi is minus 1 power n. Therefore we can write this as minus 1 power n minus 1 divided by n minus 1 minus cos of n plus 1 pi. Cos of n plus 1 pi is what? Minus 1 power n plus 1 whole divided by n plus 1. So what I have done here, I have applied the definition of cos n pi. Cos n pi value is minus 1 power n. So in place of n we have n minus 1. Just I have substituted in place of n as what? N minus 1. Now again go with the loss of indices. Pi get cancelled. So as we know that a power m plus n can be written as a power m into a power n. So I am going to apply the loss of indices. Minus 1 power n into minus 1 power minus 1 divided by n minus 1. Similarly here minus 1 power n into minus 1 power plus 1 whole divided by n plus 1. So minus 1 power minus 1 is what? Minus 1. Minus 1 power minus 1 power minus 1 power minus 1 is what? Minus 1 itself. So therefore you are left out with, you can take out minus 1 power n as common. Minus 1 power n into minus 1 divided by n minus 1. So minus into minus becomes what? Plus 1 divided by n plus 1. Now simplify this term. So continuing this, we are going to get minus 1 power n. We can rewrite this as 1 by n plus 1 minus 1 by n minus 1. So now taking LCM of these two. So it is of the form a plus b into a minus b. Minus 1 power n divided by, we have n plus 1 into n minus 1. So multiply this term here. So it is n minus 1 minus of, multiply this term as we are taking LCM. We are going to get n plus 1. So if you simplify this, minus 1 power n, numerator is n minus 1, multiply by minus n, minus n, minus into plus is minus 1 whole divided by n. A plus b into a minus b is what? A plus b into a minus b is a square minus b square. So we can write this as n square minus 1 square is 1. So here plus n and minus n get cancelled. N minus n get cancelled. We are left out with minus 1 power n into minus 1 minus 1 minus 1 minus 1 is minus 2 divided by n square minus 1. So bases are same, add the powers here. So which is nothing but 2 into minus 1 power n plus 1 divided by n square minus 1. That is what? an. That is what? an. So we got here minus 1 power n into minus 1 is nothing but minus 1 power 1 is nothing but minus 1 power n plus 1. That is what I have written here. So which becomes minus 1 power n plus 1. Therefore equation star becomes f of x equal to, the value of a0 by 2 is 1 plus summation n equal to 1 to infinity an value 2 into minus 1 power n plus 1 divided by n square minus 1 cos of nx. This is the Fourier series, cosine of range Fourier series for the given function f of x.